This is part 2 of the titration notes. We will be covering titration calculations. It'll be helpful to have a calculator, and if you have your formula sheet, it'll be helpful to have that and a periodic table available as well. So we discussed why we do titrations, and our goal is to neutralize an acid with a base or vice versa. And so what does neutralization mean? So with our acid-base reactions, we have an acid plus a base, and that is making those neutral products. And so our goal is for that acid and base to neutralize each other so we don't have any excess acid, or there aren't any excess H plus ions or any excess OH hydroxide ions, which would, if we had excess H plus, that would be acidic as a solution. If we had excess OH, that would be basic. We want each of those H pluses to have an OH to pair up with so that they are neutral. And so the goal is that we get something that has only neutral chemicals as products that are in our Erlenmeyer flask. And by getting that neutral product, it means that however many moles of acid we have, it's equal to the moles of base. So again, we have those H pluses, each pairing up with that OH. So when we're looking at it, our neutralization is going to occur if our moles of H pluses are equal to our moles of OH, of hydroxide ions. And that is the goal. So if we're going to do titration calculations, we're going to follow the same procedure as solution stoichiometry, writing a balanced equation. Then we're going to have some solution that we know the concentration and volume of after the titration is complete. And we can do that, and we can find, well, how many moles of that solution do we have? Because finding moles is equal to molarity times liters. Once we have the moles of that solution, we can use our stoichiometry, that mole ratio, to find, well, how many moles of the unknown concentration solution do we have? And then once we know those moles, we can find that concentration, because we are going to have been given a volume. And once we have these moles and volume, we can find molarity. From our formula sheet, we are going to have that molarity equals moles divided by liters formula. And then otherwise, we would need our periodic table just for writing neutral compounds to get that balanced chemical equation. All right, let's look at an example of doing these titration calculations. So with a titration, you are going to know the concentration of one of your chemicals. We are, for our purposes, going to know the concentration of our base. After our titration, we're going to be able to figure out how much was added, and we are going to have some measured out amount for our acid solution as well. So we're going to have a couple pieces of information. So as we look at this, 44 milliliters of a 0.15 molar barium hydroxide solution is required to completely neutralize 21 milliliters of an unknown concentration HNO3 solution. Our first step is to write a balanced double displacement reaction. We're given those chemicals, so I have my BaOH2, and that is aqueous because it's a solution, plus HNO3, that is also aqueous. And then this is going to be just a single direction reaction. And then as we look at our positive barium is going to pair up with our NO3. So we're going to get Ba, barium's a plus 2. So we get BaNO3 2, which is aqueous, plus our positive hydrogen is going to pair with our negative OH. And so then we get H2O or HOH. That one is actually a liquid. So here we have that double displacement reaction. We do need to balance this to take into account any mole ratio. So I have 1 barium on each side, 2 hydroxides here. This is an HOH, so that's only 1 hydroxide. So if I put a 2 here, now I have 2 H's and 2 OH's. So I need a 2 here, which balances out, I need 2 NO3s with that. So I have my balanced chemical equation for that neutralization reaction. With this now, just like with solution stoichiometry, it is helpful to go ahead and organize the information we have. So I've got 44 milliliters of that barium hydroxide solution. When we are looking at molarity, we need our volume in liters. And so I'm going to say that I've got 0.15 molar. I'm putting that under the barium hydroxide. And then I've got 1, 2, 3. So that's the concentration. The liters, or the volume of that solution, is 0.044. And then that 0 milliliters is now to liters. So I know that for this. And then my HNO3, so is needed to completely neutralize 21 milliliters of an unknown concentration of HNO3. So I don't know the molarity of that HNO3. I do know the volume that was used. And so that volume is, if we divide by 1,000 to get liters, 0.02100 liters. So this is the information I'm given. I'm trying to find this molarity. So how can we go about doing that? Well, we know that to get between chemicals in a stoichiometry or with a balanced chemical reaction, we need to know how many moles of each we have. So I need to know moles of barium hydroxide so that then I can also figure out how many moles of my HNO3 I'm going to have. And as I look at this, I have 2 unknowns for my HNO3. I have only 1 unknown, though, for that barium hydroxide. I know the relationship between molarity, volume, and moles, and so that's how we can see that this is our first step. So find the moles of our known concentration and volume solution, which is the base. So finding moles, rearranging that molarity is moles over liters. We get moles is molarity times liters. So I get 0.15 molar times 0.044 liters. And then I get 0.0066 moles of barium hydroxide, BaOH2, is how many moles of that base that I have. I dropped my zeros on the end here because this was 2 sig figs. And so then I just dropped it without having to write the zeros. So that's how many moles of barium hydroxide I have. I now know this piece of information. So then to get from barium hydroxide to that HNO3, our second step is going to be to do that stoichiometry. So our second step is to do that stoich, because that's going to take into account any mole ratio we might have. So I'm taking my 0.0066 moles of barium hydroxide. We want to figure out information about our HNO3 solution. And so I'm going to set that up so that I can get rid of, I've got my barium hydroxide, moles on the bottom. I want moles of HNO3, my acid. And where do I get those values? Well, I have 2 moles of HNO3 to 1 mole of our barium hydroxide. So that's the mole ratio. And these units cancel, moles of barium hydroxide, and we get that number multiplied by 2, 0.0132 moles of that HNO3. All right, now going ahead, and this number I think I just kept in my calculator as we go through. Remember, these don't have sig figs. I'm going to make sure my sig figs are correct all the way at the end. So taking this, now I know my moles of HNO3, so I have this value here. Once I know that I've got 0.0132 moles of that HNO3, my third step is to use that molarity formula again to find what is the concentration of that acidic solution. So finding our unknown concentration, that molarity. Well, the molarity of our HNO3 solution, and again, if you want to write it as concentration of HNO3, is going to be moles over liters. We found moles from our last step using our mole ratio with that stoich, dividing by, well, how many liters of that solution do we have? Our problem told us we had those 21 milliliters. So dividing by 0.02100 liters like that. Going ahead and doing that division, I get 0.6285, and then that kept going. Looking at, again, all my values for my final sig figs, because I've just been multiplying and dividing. So doing those final sig figs at the end, kind of keeping my values in my calculator. This is 4 sig figs with those zeros to the right after the decimal. This is also 4 sig figs. This is 2 sig figs. So let's keep 2 sig figs in our final answer. So 1, 2. So this is going to be 0.63. And that is the concentration molarity. That's 0.63 molar HNO3 solution. Like that. So just adding, combining together our molarity, how we classify those solutions, and our mole ratio. All right, looking at our next problem, I gave us a reaction, thinking of how do we even get started on this one. So we've got the reaction, it's balanced and neutral. We've got 24.7 milliliters of HCl solution that is completely neutralized by 35.8 milliliters of a 0.25 molar NaOH solution. What is the concentration of the HCl solution? So as we're looking at this, I have 24.7 milliliters of HCl, and I don't know the concentration of that. That's what we're looking for. But if I go through here, I know that I'm looking for the molarity of my HCl. We've got 24.7 milliliters, 1, 2, 3. Let's change that to liters, because anytime we're dealing with molarity, we want liters. So the volume of that solution is 0.0247 liters. That is being neutralized by our NaOH solution. We've got a concentration for that solution of 0.25 molar. Volume is 1, 2, 3. We've got 0.0358 liters. And that is the information that I'm given. So how do we get from here to here? Just like we did the last time, we know 2 pieces of information about that. And in order to go between our chemicals, we need to know moles. So my first step is going to be to find moles of that NaOH using that molarity formula. My second step then, once I find this value, is to find moles of our HCl. So we can do stoich to go from moles of NaOH to moles of HCl. And then once we have those moles of HCl, then we are able to figure out the concentration. So what is the molarity of our HCl solution using that moles divided by liters. So if you feel comfortable, go ahead and start kind of work through that process. Pause the video, and then I've got the solution on the next page. All right, so my colors changed a little bit, but that same kind of process here. First thing is writing our reaction, so my numbers are a little bit off because I wrote the reaction here, and then there's my work. My final answer being 2 sig figs based off of our 2 sig fig concentration we had, 0.36 molar HCl. So this is kind of a long process, but it is short steps once we get the hang of it. There is a titration equation. It is not provided on your formula sheet, but if you remember it, this kind of combines everything that we know. Because again, the goal of our neutralization is always, or our goal is always neutralization, in a titration, and this formula comes from the fact that molarity times volume is moles. And so this titration equation, if you can memorize it, then you can use that. And again, it comes from that basic idea of neutralization. So molarity of A, so capital N is molarity, V is volume. Molarity of acid times volume of acid is times the N, the number of H's or OH's in the acid-base compound, Na, is going to equal molarity of B, our base, times the volume of our base, times the number of OH's in our compound with that. One thing to note is that it is just how many H's. So because we need this to be a balanced reaction, HCl has one hydrogen, so that would be a Na of 1. NaOH would be a Nb of 1. H2SO4, because there are 2 hydrogens, we do need to use an Na of 2, even though it would only dissociate one of those. And so we can use this formula. We should get the same thing as our process above if we are looking at a problem, a titration problem with that. So we've got 44 milliliters of a 0.15 molar barium hydroxide solution is required to completely neutralize 21 milliliters of an unknown concentration of HNO3 solution. Solve using the titration equation. So as we're looking at this, I have 44 milliliters of barium hydroxide, so that is my base. And then it's required to neutralize 21 milliliters of our HNO3 solution, which is an acid. Organizing my information, I'm going to just say, okay, here's my molarity of my acid, volume of my acid, and then Na, how many moles of H's do I have in that? And then my Mb, Vb, and then Nb. So looking at these 44 milliliters of 0.15 molar BaOH, that's going to be these values here. We've got a concentration of 0.15 molar. My volume, 1, 2, 3, 0.044 liters. Nb, this has 2 OH's, and so that Nb is 2. Looking at my acid now, we have 21 milliliters, so moving that decimal 1, 2, 3, 0.021 liters. Of an unknown concentration, we're looking for molarity of A. HNO3 solution, I have 1 H, so my Na is 1. So I have all but one piece of information here. Our compounds were provided for us. If we didn't know our compounds, we would need to write neutral compounds so that we could figure out the hydrogens and the hydroxides in each for our N values. But now I can go ahead and plug these in. I'm looking for Ma, so Ma times that 0.021 liters times 1 is going to equal Mb 0.15 molar times 0.044 liters times 2. And you'll notice here that our molarity, our liters units cancel here, which means that the only unit I'm going to be left with is a molarity unit, which is why our answer is going to get that value as well. As we go through, we've got Ma times 0.021 equals, as I multiply that 0.15 times 0.044 times 2, I get 0.0132. And then to solve to get our molarity of our acid by itself, divide by 0.021 on both sides. And the molarity of A is going to be 0.0132 divided by 0.021. And I get 0.62857 in my calculator. Considering sig figs, our N values are exact. We only have a whole number of hydrogens or hydroxides. So looking at our calculations, we had 4 sig figs here, 2 sig figs here, and 4 sig figs here. And so the least of those is 2 sig figs, so we're going to keep the 6. And then that is going to round, so the molarity of our acid is 0.6. The 8 is going to round that 2 up to a 3, so 0.63 molar, and that is the concentration of our HNO3 with that. And the last part of this question asks, did we get the same answer as in example 3, so that 0.63 molar? As I go back up to example 3, that is what we got here as well. So it was the same problem, we just solved it 2 different ways. So yes, we did get the same answer. So again, you can use the titration formula if you remember it. Otherwise, it is just solution stoich. As a challenge problem, there's one provided here for you. Go ahead and give that a try if you want. Answers are provided. Feel free to check in with your teacher if you have questions on that. And there is a titration worksheet as practice, and you will also be practicing these calculations in the titration lab. Reach out to your teacher with any questions.